One idea that goes hand in hand with rate of change is identifying intervals of increase and intervals of decrease. Looking at the first graph that we have in example 10, we can see that that changes at some point. For the first half of this curve, our function is decreasing because our y values are getting smaller and smaller as we read from left to right. And the other half of the graph, the y values are getting larger and larger, so our function is increasing. We can translate that idea into interval notation to indicate where our function is increasing and decreasing. For the left half of the curve, we're decreasing, so that means we would be decreasing on the interval from negative infinity up to 0 with a rounded parenthesis. On the right-hand side of this graph, we would say that we're increasing from 0 to positive infinity. Because in both cases, it's implied that our graph just continues heading in that same direction. We can also describe the domain of this function. In this case, there are no breaks in the graph, so we would say that the domain is negative infinity to infinity. Looking at the second curve, this one is increasing the entire time. So we would say that the interval of increase is 0, and we'll use a close bracket this time since it starts at 0 and continues to infinity. On the first graph, we use rounded parentheses at 0 because that's that point of change between decreasing and increasing. At 0, the function's not really increasing or decreasing, it's just kind of that changeover point. But in this case, the function is increasing on that entire interval, so we'll include 0 as part of that interval. In this case, we do have a restricted domain. Since our graph never travels below x equals 0, our domain will be close bracket 0 to infinity. We want to do the same thing in example 11, identify where our function is increasing, decreasing, and state the domain. We can see our function is increasing on this first section and this third section, but we have a middle section where it's decreasing. Our y values are going down as we read the graph from left to right. So we would identify the intervals of increase as negative infinity up to negative 6, because that's where that change happens. We use a rounded parenthesis. And we also have an interval of increase from 2 to infinity. And we'll join those two intervals with that U symbol. So the union of those two intervals, or the intersection, the union of those two intervals is where our function is increasing, either in the first interval or the second interval. And then we could identify our function as decreasing on the interval from negative 6 to positive 2. In this case, we have no holes or breaks, no jumps in our graph, so our domain is unrestricted. It would be negative infinity to infinity. In example 12, we have a restriction in our domain in this case. It's not graphed on here to start, but we can see that what's happening is there's a vertical line passing through x equals 1 that our function is approaching from both directions. This is referred to as a vertical asymptote. What that means is it's a vertical line that our function will approach but never actually intersect. So for this function, if it's a function f, it means that f of 1 is undefined. So in terms of our domain, we have a restriction. The domain would be negative infinity to positive 1, union positive 1 to infinity. We include that break at 1, and we use rounded parentheses because the function itself isn't defined at 1. So inserting that break indicates that we have that point where our function's undefined. Then looking at the intervals of increase and decrease, we can see that our function is decreasing to the left of that asymptote as well as to the right of that asymptote. But we still need to include that break since our function is undefined at 1. So we would say that our function is decreasing on negative infinity to 1, union 1 to infinity. As for where our function is increasing, it's not anywhere. So there are a couple of different ways we could indicate this. We could either state DNE for does not exist. There is no interval where the function is increasing. Or we could use this symbol of a 0 with a slash through it. That's referred to as the null set. But regardless of the notation or the way we indicate that, our answer should be that there's nowhere where our function is increasing.